Welcome to AI and the Law. I wanted to introduce our speaker for guest speaker this week, Dr. Ben Chung. He is a friend of mine and he is an engineer at Nokia. So he'll be talking to us about the history of AI and where it is currently from a technical point of view, which I find very helpful for understanding how it works. I turn it over to you, Ben.
Just a little bit about myself. So, wireless technologies for quite a long time, since 2G, for 27 years in the industry. Currently working on ORAN, which is Open Radio Access Network 5G standards, working on 5G wireless, focusing on cloudification orchestration and network slicing and architecture work. I've worked on ONAP as well, Open Network Automated Platform, which I still work on. I do use AI in my work. I can't talk about it too much, but suffice it to say, it's part of part of my work. So I've worked at Lucent Technologies, which became Alcatel-Lucent and now Nokia. I also was a software engineer at General Electric Medical Systems, working on ultrasound and MRI. I have a number of patents and a number that are patent pending as well. And I did my master's in bachelor's and master's in electrical engineering and PhD in operations research. I've been to 31 countries around the world. I speak in 3 languages, and I've written 6 books, and my latest books are the periodic Table of Ideas in 2021 and the 4 Elements of Thinking in 2019. And I've published a number of games called the Tech Deck, and I was a former HeroClix World Champion, a chess-like game. Okay, so I'm going to talk about basically 4 kind of areas, like what are the big ideas in artificial intelligence and machine learning? When and where did AI ML develop? What are its milestones in history to give you a sense of the timeline of AI ML and how it came to be, and a little bit of maybe where it's going. And how is AI ML used, and what are its practical applications, and who are some of the big players, and maybe some of the things that they're doing. First we'll cover just an overview and some of the key concepts. What are the big ideas in AI and ML? Well, to talk about the I in AI, it probably helps to think a little bit about what is intelligence, right? So we all kind of know maybe intuitively what intelligence is, but maybe a little bit more formally. There's a number of different things that characterize intelligence, and different books and sources you will read will sort of point you to different things and highlight different things. So this was just a book from AI for Dummies, but you can certainly, it's a good, useful rule of thumb for thinking about it. So the ability to learn, to obtain and process new information, reasoning, the ability to manipulate information, understanding concerning the result of information manipulation, comprehension, to be able to grasp truths, seeing relationships, defining how data interacts with other data, considering meaning, so applying truths to situations in a manner consistent with the relationship, and separating fact from belief, so determining if data is supported by sources. And a famous person, Howard Gardner, in his book Frames of Mind, The Theory of Multiple Intelligences, published in 1983, said there are 7 kind of intelligences. He defined visual spatial intelligence, that is like the physical awareness of your environment, bodily kinesthetic intelligence, or proprioception, precise body awareness, such as a skill that surgeons and dancers exercise. A creative intelligence, that is the ability to develop new patterns of thought with unique output in art, music, and writing. Interpersonal intelligence, to be able to obtain, exchange, give, and manipulate information based on the experience of others. Intrapersonal intelligence, the ability to look inward to understand your own interests and setting goals based on those interests. Linguistic intelligence, and to be able to understand spoken and written language to develop an answer and provide a cogent answer. And then logical and mathematical intelligence to be able to calculate results, perform comparisons, identify patterns, and consider logical relationships. So that kind of gives you at least a sense of what intelligence is. And then we'll talk about some of the big areas or big ideas in AI. And this one slide, I think, kind of captures my entire talk. So um, if you take nothing else from this talk, or if you want to return to a particular part in the video, this is the slide, or this is the part to return to. So there's 5 major divisions or areas, let's say, of AI. One is predictive analytics, being able to predict future outcomes using historical data and statistical modeling. So lots of algorithms um, are able to take a look at data and utilize algorithms or modeling and to find trends or predict outcomes. Artificial intelligence is programs and machines that learn and reason and make intelligent decisions. Machine learning today goes kind of hand in hand with AI, and we'll talk a lot more about this. So machine learning is defined as machines that learn through experience without explicit programming. And the neural networks are also intimately tied to the concept today's in 2023, like machine learning. Connected elements that process data, adapt, and learn from the past patterns. So neural networks has been around for decades, and again, we'll talk more about this coming up. And then deep learning, artificial neural networks, ANNs, that can adapt, learn, and make intelligent decisions. Okay, so again, a key slide here that you want to keep in mind throughout the talk. So there's stages, let's say, of artificial intelligence. Today we're at this what's called ANI, or weak AI, with kind of narrow capability, or artificial narrow intelligence. In the 80s, we kind of had expert systems that are algorithmically driven, and those are still kind of with us today. And we have data mining and pattern recognition, human-computer partnerships, and navigation systems are examples of weak AI. Artificial general intelligence, or strong AI, is much more generalized capabilities. So with the ability to recognize, to learn with machine vision and natural language processing. And then ASI, or strong AI, artificial superintelligence, has some transcendent ability, the ability to innovate, to create, to imagine, to decide, plan, and forecast with advanced robotics and communication. So some examples of narrow AI we have today. So like Bard and ChatGPT, Echo, Alexa. So they're fairly narrow capabilities, even though they seem quite intelligent, and they are quite capable to some degree. There you can interact with it, and it's doing more and more. Each time I give this talk, it's pretty impressive how far AI is coming along. But to see examples of AGI, or artificial general intelligence, and super intelligence, we have to look at science fiction movies, and that's not necessarily a great, maybe a good. They're not necessarily great examples in the sense that science fiction movies have to come up with some sensational kind of story, but at least the things that are depicted there can give you a kind of sense of AGI and ASI. So Wall-E, for example, is something is a robot from the movie Wall-E that can see, learn, talk, and engage with its environment. And then something like Megan in the movie Megan, or Data from Star Trek, or the robot in AI, the boy in AI, is basically self-aware and can consider, like, what's the meaning of life. Okay, so for machine learning, there's 3 basic kinds of learning here. So one is unsupervised learning, where the program can find hidden patterns and data groupings, and supervised learning is where it trains off sort of patterns. So you have a target that helps it to learn. And reinforcement learning is it takes input data and corrects the output data by learning from mistakes. So in unsupervised learning, you have a bunch of data. It's looking at clusters of unlabeled data sets. It can do big data visualization. In supervised learning, it's classifying data and perhaps doing regression and forecasting and predicting. And in reinforcement learning, it can make real-time decisions, acquire skills, and learn tasks. So here in this cartoon, we see an example of supervised learning versus unsupervised learning. So we see in supervised learning on the left, um, the machine is trying to identify a particular object, like a banana or an apple, and something tells it that it's getting close, right? So things that we thought were, and we'll see this kind of in the history of AI, but one of the things that we learned is that through the decades of AI development is that things we thought once were really hard turn out to be not quite as hard as things that were actually we thought were easy turn out to be a lot harder. So for example, playing chess we thought was extremely difficult because just of all the possible positions on the board turn out to be difficult, obviously, but not actually as hard as like computer vision, which because we can walk across the room very easily and differentiate objects and things between shadows, we thought, well, that should be simple, but it turns out to be extremely difficult. And recognizing a cat in a photo is something like examples of things that are used in supervised and unsupervised learning. So on the right here, we see unsupervised learning, where the program isn't given any instructions or any guidance. It just is able to find interesting patterns and groupings here. So we see in the picture here, it's grouping, well, those bananas are bananas and those apples are apples, but it's not giving any further direction beyond that. Okay, so this is a fairly busy slide, and I wanted just to show that we're just really scratching the surface here, that there's lots and lots of different kinds of interesting algorithms that have been developed over the decades. And there's lots of different kinds of techniques that have been employed and used and developed for AI/ML, and it's really seen a renaissance. And we'll talk about some of the AI winters here coming up in the history of AI. But yeah, I just want to leave that you with in this section with a sense that there are lots of interesting techniques that people have thought of towards AI and ML. Okay. So in this next section, we'll talk about some of the big milestones in AI/ML. What are the key developments and some of the interesting things that have signify the history of AI. So in 1950, Alan Turing posed the Turing test as a measure of machine intelligence. What does it mean to be human? And the Turing test is pretty famous. So basically, it describes a test where if you were talking to somebody electronically, say behind a screen that you can't see, and you couldn't differentiate between a person and a program doing that, that would be an adequate test of AI, something that's artificial intelligence. In 1956, John McCarthy coined the term artificial intelligence for the Dartmouth College Summer AI Conference. In the 1960s, Ray Solomanoff lays the foundations of mathematical theory of AI, introducing a universal Bayesian methods for inductive inference and prediction. Bayesian methods are introduced for probabilistic inference machine learning. And that's basically saying I have a series of events and and I consider evidence and given prior probabilities, what's the chance of an event happening, right? Now, in the 50s and 60s, there was a lot of interest and a lot of hope and promise that, remember, we're kind of entering the space age. And in general, there's a lot, we're landing on the moon and that sort of thing. So there's a lot of optimism about technology. And AI, it doesn't pay off yet, right? Like computers aren't quite powerful enough yet, even though some of the theory is there. So in 1974 to 1980, there was what was called an AI winter. There was a lot of investment made in this period of time, but it didn't pay off, and because it didn't pay off, people sort of lost interest, and so we head into a point where is called like a winter, where less work is done and less interest is taken. But then in the 1980s, the use of backpropagation algorithms causes a resurgence in machine learning research. And the basic idea of backpropagation is to take the output and train it as input. So like a feedback loop is probably two words to describe that idea. And it's a very powerful idea, you know, which is the basis still of learning today, right? Of AI and ML today. But again, we head into another winter in 1987 to 1984. But then in the 1990s, a shift from knowledge-driven approach to a data-driven approach with support vector machines, SVMs, and recurrent neural networks, RNNs, become popular. So a neural network is basically emulating like human neurons, where you have an input layer, a hidden layer, and an output layer. And the input layer, it takes input from different, like say, different elements, data, and then it's organized similar to the way the brain is organized with neurons. So the thinking is that if you can, it works in the human brain, like, maybe some electronic um, emulation of that will be promising. In 1997, the IBM program Deep Blue, which was a chess machine, defeats the then world chess champion Garry Kasparov. And again, this was hailed as miraculous and like, wow, that's incredible that a computer program could defeat the world's best chess player. In 2002, iRobot introduced the Roomba, which is an autonomous robot that vacuums the floor while navigating and avoiding obstacles. And what's kind of miraculous about this device is that, the home, like a person's home, is actually a very difficult, an extremely difficult environment for a robot to be in. Think cats and dogs and kids and just stuff all over the place. Like, it can be a very chaotic environment, right? And of course, it would be very bad if a robot accidentally ran over a cat or a dog or injured your child. So to have something that can go around the house and perform, a task of any kind is very impressive, right? Um, in 2005, Honda's Asimo robot, which was an artificial intelligent humanoid robot, can walk as fast as a human, delivering trays to customers in restaurant settings. So it's a really impressive, robot. I wrote a book on robotics, and I used Asimo as one of the highlights of illustrating, what it can do. So if you can go on and watch videos of some of the robots that are available today are quite impressive, actually. So in the 2010s, deep learning becomes feasible, which leads to machine learning, which becomes integral to many widely used software services and applications. And we'll see some of that in later sections of this talk. 2011, Amazon introduces Echo, a voice-controlled intelligent personal assistant, service Alexa, and it's pretty impressive, what it can do, and the notice again, it's in a home setting, so it's not like the science fiction thing you see where a robot that can walk around and talk and has arms, but it's just a cylinder, right? And but yet it can do essentially very intelligent things. And I think some of the early forms in the robots will be like that, just um, simple shapes and simple, doing a narrow set of tasks. In 2016, the Partnership on AI to benefit people in society formed for the responsible use of AI, and it researches best practices for artificial intelligence systems and to educate the public about AI. In 2018, Hiroshi Ishiguro.
Ben,
Oh, yes.
I just wanted to comment that the partnership was formed by some of the big tech companies for that. That was
Yeah.
who initially started it.
Yeah. 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 I think it's as we we'll see in a couple slides here and two slides coming up. I think, thinking about AI before it really hits that sort of singularity point is really important, right? Like, and the class that you're going to take here is going to explore some, I think, really interesting and important topics of the law and things that are thinking about AI before AI really takes off is really important to lay the groundwork. I think is very important. So anyway, in 2018, Hiroshi Ishiguro created Erica, the world's first robotic humanoid news anchor in Japan. And there was there's this 230-page artificial intelligence index report from 2022. And this is the summary of that, right? So it says private investment in AI soared. U.S. and China dominated cross-country collaborations on AI. Language models are more capable than ever, but also biased. The rise of AI's ethics is increasing. AI becomes more affordable and higher performing. It's all about data. More global legislation on AI is occurring, and robotic arms are becoming cheaper. So just some of the trends that happened in 2022. Some of the trends we think we'll see in 2023 are generative AI algorithms will become more prevalent. You probably heard of ChatGPT, OpenAI's natural language processor. Bard is Google's natural language processor. It's equally as impressive as ChatGPT, I'd say. And the ability to model and process questions and which opens questions about co-creation and you can ask it to, like, say, create the lyrics for a song, and if you're a musician, did you create the lyrics, or if you co-created the lyrics, who really owns those lyrics? There's lots of other, and we'll see some more examples here when we get to the later sections of the talk.
Yeah, and then related to that, one thing we're talking about in the class is actually the copyright angles behind and patent and trademark angles behind that co-creation and what the law has become in that area, which I think will be really interesting for the students.
Yes, it opens up lots of interesting questions for sure. Another area is augmented working. So robots that can assist humans with work, partnering with humans. And again, we'll see some of those in the later sections of the talk. AI-powered virtual assistants will also become more prevalent in the workplace. A democratization of AI, no code and low code type platforms that enable anybody to create, test, and deploy AI-powered solutions using simple drag and drop or wizard-based interfaces. Things like Sway AI and IKEO are examples where it makes it much easier to to use AI. So that the AI programming that I've done requires, like, you to know software. I was a software developer for 10 years, and it's there's a lot of knowledge you already need to know in order to how to program any kind of language. But now we're seeing, I think, the rise of what's called no code and low code platforms. It makes it much easier for just anybody to code. We touched on, again, ethical and sustainable AI, and those are two separate topics, but kind of grouped them together. So making AI ethical and unbiased, and AI initiatives for sustainable and planet-friendly solutions. There's one example of this is the black box problem of AI, where basically because neural networks train and learn and develop just like your brain, you don't necessarily know how something goes about making its decision. Like when you make a decision to choose a particular flavor of ice cream, you don't necessarily know, unless you really kind of think about it, how you came to make that decision. And even then you think, well, it's just a preference I have, right? But when it comes to AI, like when a self-driving car makes a decision to turn left or right, or some other AI makes some sort of decision, that might be a problem if we don't know kind of what's under that black box. And that's called the black box problem of AI. But that's, anyway, related to this area of ethical, sustainable AI.
So Ben, since you do some stuff with AI for work,
Mm.
we will talk about the black box problem more with the students and how it's hard then to create AI transparency, which is helpful for ethics given the black box. Can you
Sure.
just explain a little bit more about that for the students? I know that one piece is that because of how we program AI and then AI develops further, it can be hard even for the programmers to understand why it's making the decision it's making. Is that true in your experience?
Yeah, sure. So So a lot of what, and actually, how I don't, today I don't program AI as much as I kind of treat it as a black box and at my work. So actually, I in the sort of systems architecture stuff that I do, I take lots of entities in a wireless network, and they're all black boxes, right? They're all things that come together to make a call, a telephone call, for example, a wireless telephone call. And AIML is one of those black boxes that says this has this particular function, and I'm expecting it to do this kind of function. But the thing is that it's kind of like a magic box, right? It does this particular kind of function, and it has a particular thing it needs to do. But I don't, even as an engineer, I don't necessarily specify all the little steps that it takes, and or how that application comes about, right? So and part of that is because that function might be provided by different vendors. I might have an off-the-shelf solution for that thing, or we might develop it in-house. So one problem, of course, is maybe well, it could be in practically any industry, but think about like the medical or healthcare industry. If you have a AI assisted surgeon, and somebody's arm or health is on the line, and something goes wrong, uh, uh, how did it make the decision when you have like a convolutional neural network or a neural network, right? And it's learning over time. There's weights that are associated with the neurons, with these sort of digital neurons. But all those weights and neurons come together to make a decision. It's not easy to necessarily decompose how that decision was made. It's not like the traditional lines of code where I have a subroutine at line 32. If X is greater than Y, then I take this particular action. It's not algorithmic as much as the traditional types of software are. But that brings interesting questions of well, if it makes a wrong decision and somebody got hurt, for example, who's to blame, or how do I figure out why it made that decision? It's an interesting modern age sort of problem to consider. Okay. Um, and a little look at the future. So today we kind of have this enhanced narrow AI capable of a task, but being perhaps very good at a task and partnering with humans to enhance their capabilities or to enhance something they're doing. And these dates, I will emphasize, are very they're very speculative. But they at least highlight sort of some milestones. So AI initiated operations, art, software, and mathematical solutions, research papers that are initiated by AI programs, and then eventually we'll see general AI with full cognitive capabilities, mimicking a human, and then super intelligent AI with cognitive capabilities beyond a human and machine consciousness. So I had read a book. And it was either, let's see, I read a lot of books. So I think it was either All In on AI or Intelligent Automation, where the author mentioned that there was a survey of like 100 different AI researchers, and they all had widely varying numbers for dates for when we might hit AI superintelligence, and that's called that singularity. Ray Kurzweil's concept of the singularity, where we hit that point, it'll be very impressive, and the entire world will change when we hit that point. But in my mind, I think it's more like a pyramid, right? I think we're going to see um, a sort of gradual evolution towards more and more smart things, and we'll see. It won't be like yesterday there wasn't AI and suddenly today there's AI. You'll see just more and more everything becoming smarter and smarter, I think. So today we see machine learning, and gradually you'll see some things just get more and more intelligent, and when it hits that sort of stage 2 machine intelligence, just things will be a lot smarter. And then finally, maybe stage 3, where something is self-aware or machine consciousness will truly be quite a milestone. But in other areas, I think it'll be much more evolutionary.
What's the difference between what we have now, like ChatGPT, and enhanced narrow AI?
So that's kind of going back to the different areas of AI, right? So
Right.
so Bard and ChatGPT actually maybe yeah. So like if I have ChatGPT up here, so we see this is an example of Bard, right? So and this is ChatGPT. So Bard, you can ask it things like, what should I'm going to Japan in June here. So what should I pack, let's say, for my trip to Japan, right? And it'll come up with, some a list of things for my trip that I'm about to take next month. Um, and but this is an example of this is an example of artificial narrow intelligence, right? So it's kind of like a super search, right? Like a super Google, right? So
Right.
so I can ask it things and it can respond, but I'm not really having uh, a, uh, an actual conversation really with Bard, right?
Although some people think they have, right? There was
Yeah,
that,
yeah,
so that Google
yeah.
engineer. Yeah.
Right, right. So but in the end, I mean, it's not aware of itself. Like, I think if
Right.
you ask it, like, are you self-aware? I'll say it's not self-aware, right? So, are you aware of itself? These are just
I am not sure.
I'm not sure if I'm self-aware, right? But so it can answer anything you ask of it intelligently, um, but it's not really truly aware of its environment.
Right.
It doesn't really initiate a conversation, much as like is depicted in movies, right? So
Right.
so and again, I think things like Bard and ChatGPT will be incorporated into more and more things. So just things will seem much more intelligent, and eventually it will, in parallel, we'll see developments in robotics that do allow things to interact and learn about its environment. And we'll see some of that also in the applications of AI section of this talk. So okay, let me get back
Thank you.
to yeah. Thanks for the question. Um, okay, all right. Okay, so in this next section, we're going to talk about some of the practical applications of AI. And really, I think AI will kind of pervade everything. I mean, it's kind of like think of just about any area of your life and anywhere you might go or interact. I mean, AI will be everywhere and will infuse just about everything. Um, but but we can think about it maybe a little bit more um, in certain areas, right? So like machine vision, language processing, and robotics are some key areas where AI is seeing a lot of attention. So one thing that's very important is for a robot or a program, a smart thing, to just interact with a person or to interact with its environment, it has to be able to make sense of the world, just like we do, right? So um, and that problem of machine vision, which has really been around for many decades, right? So since I've started first, doing anything with AI, some 30 years ago, um, machine vision was always a difficult thing to do, right? So we think it's trivial to see an apple, that's an apple on the table, right? Um, but but shadows and other objects, and if you see only a third, like a person only needs to see a tiny fraction of an apple behind a box, and we know there's an apple there. Um, and we may even just see the shadow of an apple, and we say, "Oh, there's an apple behind that box." The sunlight, hits it just at the right angle. But that's actually an extremely difficult thing for a computer. That's a very difficult computer problem. So being able to recognize an image, being able to sense motion, being able to reconstruct a scene, or restore an image, those are areas of machine vision. Language processing has come. Both of these have actually come a long way in the past couple decades. So natural language processing with automatic speech recognition and natural language understanding and natural language operation and text to speech. Um, these are areas that are very amenable to machine learning and big data. So like ChatGPT, which is processes trillions of words and things is you see the impressive ability of Bard and ChatGPT to understand language is quite impressive. But I also for work I'm on calls like all day long, and sometimes I create videos and things. And the transcript isn't necessarily good, especially if you have if English isn't your a native language to you, right? Like I still look at some of the transcriptions and they're not they leave something to be desired, let's say. So there's still ways to go, still a ways to go there.
Huge
Robotic.
problem, huge problem with accessibility right now is how bad the text-to-speech ones are. It's a huge
Yeah,
problem with
yes,
that.
yeah. I think that'll improve, that'll improve over time, certainly.
Yeah.
And then robotics. So putting some of this together, being able to start to actually interact physically with the environment will require some robotics. So, and that has all sorts of interesting interesting things to consider as well, like power sources and power management and sensing its environment and that human to robot interaction and mobility and locomotion. So we see robotics will be used in lots of different settings. But today robotics is very useful. So in like a factory setting, be able to do a very specific thing in a particular area, doing this particular motion. Robotics today are very good at that particular thing. I need to move this part over here. It may be a very heavy part, or I may need to drill this particular screw or bolt into this particular place. It's very good at that right now, right? But we'll see more generalized robots like a Super Roomba, or there are also Roomba robots and a lot of other. Actually, if you look at the chapter, if you read my chapter on the periodic table of ideas, the chapter on robotics, I researched some of the more modern robots, and they're pretty interesting. Some of the things that have been already created. Natural interfaces. So at some point, in order for them to be useful to us, there has to be some sort of human to computer interface, right? So speech recognition, natural language understanding, understanding hand and eye gestures of people, some brain or computer interfaces, touch surfaces, and virtual reality, augmented reality, mixed reality, AR, VR, MR, and then cognitive systems. So useful systems that will partner with us. So smart agents and robots, expert systems, recommendation engines. I bought this. I see you bought this movie, and you might want to try this movie. Adaptive learning systems and translation systems. So again, we'll see some more examples of this coming up. And then some simple examples are movie and song apps. And smart cities and public buses, smart home devices, Industry 4.0, social applications, and personal assistants. So in the home, we'll see AI in lots of different areas. So in security monitoring, environmental control, entertainment, communications, informatics, profile execution, audiovisual systems, energy management, safety management, telecontrol, appliance control, lock and access control. And we're already seeing lots of products in each of these areas, right? So like the smart doorbell Ring, for example, is just one example of where you'll see applications in all these areas, but that's just one simple example, right? A smart city, so handling emergency services, power management, disaster recovery, public safety, public transportation, smart parking, augmented reality, the Internet of Things services, connected car services, sanitation management, transportation analytics, water management. So you'll see AI kind of infused into like intersections and parking apps that can help you find parking spots, and buses that can help bus drivers or update users on live wait times, emergency departments that can receive alerts to accidents as they happen, smart trash cans that can notify waste management when they're full, smart street lights that turn on instead of just always being on, just turning on when they need to be, and intelligent solar panels to renew energy and power the city. And this concept of Industry 4.0 is a term that you'll hear. So Industry 1.0 was that initial industrial revolution. The steam engine here we see. Industry 2.0 was characterized by mass production, the assembly line. Think the Ford Model T and electrical energy. Industry 3.0, and we're kind of in the transition from 3.0 to 4.0, but the modern factories are like Industry 3.0 with automation and computers and electronics. And then Industry 4.0, like the cyber physical systems, the Internet of Things, and advanced networks and AI-infused systems. So we'll see things, AI be infused in safety monitoring, assembly line management, just-in-time management, enterprise resource planning, cyber physical systems, the Internet of Things and machine-to-machine communications, RFID controls, factory security, advanced robotics and programmable logic controllers, and manufacturing operations management and management execution systems and supervisory control and data acquisition. So some of the like we have at where I work in Nokia, we're working on Industry 4.0 is one of the things, and it's pretty cool to see some of the demos. So like just smart deliveries of things, factories that can reconfigure themselves, smart advanced assembly of things. You'll see lots of really neat stuff that's sort of behind the scenes that you may not, as just a buyer of consumer products, you may not see, but it's going to be very interesting, I think, just with the advancement fusing AI into industry. So in this last section, we're going to take a look at some of the players, and now I'll preamble this that there are hundreds of companies doing stuff with AI, and even companies that you wouldn't expect or normally associate with AI are doing stuff with or using and employing AI, like Kroger, for example, right? So the grocery store chain. But we'll highlight some of the well-known players and maybe some of the less well-known players. So Microsoft, of course, has programs on AI, Project Oxford, Cortana, IBM, the famous Deep Blue, and Watson. Amazon, you've probably heard of Alexa, the Echo, the Amazon Echo, and Amazon ML. Salesforce as a partner to sales team type thing, to applications, Tempo, and Salesforce IQ. Apple with Siri, Perceptio, Emotion, and Vocal IQ. Facebook's M and Deepface and Fair. Google's TensorFlow, Google Now, and Google Brain are just a few examples. I watched a Google AI in 2022, which is an interesting lecture on AI, and it highlighted some of the things that it's doing. So AI for social good, to handle disasters and health management, and AI for creativity. Its programs like Party and Imagen and Finaki are really very interesting. So being able to take natural language and to create images is what Party is about. Finaki is very interesting. Just do a search on it, and basically you'll see demos of where a natural language description of a movie creates a video, right? So that's kind of what Finaki is about. AI for language, of course, Google Translate is a very popular app, and it's constantly adding new languages capabilities for it. Microsoft's doing a lot with AI as well. An innovation sandbox, business scenarios, AI for society, autonomous systems, security and responsibility. So platforms for simulated intelligence, datations, virtual stages, sketch to code, Angel Eyes and Clean Water for Society, air simulation drones and intelligent robotics, machine teaching, and security and responsibility, synthetic data showcases, differential privacy and homomorphic encryption, responsible conversational AI. And Amazon, in the areas of computer vision, recognition, lookout, and panorama, data extraction analysis, so tech extract, comprehension, and A21, language AI, Lex and Transcribe and Poly, customer experiences like Kendra, personalize and translate, business metrics, forecast and fraud detection, lookout, code development and ops, a DevOps guru and code guru, industrial AI equipment lookout and Monitron, healthcare related AI enhancements like Health Lake and Comprehend Medical. And these are from a book that I read in 2023 called Working with AI, Real Stories of Human Machine Collaboration by Tom Davenport and Steve Miller. Now the book highlights about 20 plus different things, but so this is just a small sampling of them. But an application called My Skin, it's a dermatology as a service application, AI-driven skin monitoring application. What you do is during the pandemic, it was hard to actually for people to visit their dermatologist. But this app that was developed, you can regularly scan your skin and with using your phone's camera, and it can look for changes and patterns to try to detect lesions and carcinoma detection. This will be one of particular interest to this course. Kira, so OstlerWorks developed this system called Kira. It's an AI-empowered legal services delivery for automated discovery, e-discovery, due diligence, and content extraction. So I would suggest you look into this. Very interesting. Grab Health, one of many healthcare apps that will be up and coming. So this is one example of mobile medical telemedicine and an ecosystem of products. Lilt is now of course you've heard of Google Translate, but they're actually translation services are kind of still a big thing, right? So having a human partner with an AI to help translation and contextual AI engine for translation with a human in the loop collaborative translation greatly enhances a translator, somebody whose job is to translate, say, textbooks and things, is the function of this company Lilt. Flippy, so from Miso Robotics, it's a fast food preparation machine, AI-enhanced vision-assisted robotic food preparation machine. It's quite expensive, but pretty interesting to see it in action. You can see videos of it from Miso Robotics, and it can prepare for lots of different kinds of foods. So we see here some more tangible examples of companies doing specific things with a enhanced functionality. Now, I think one thing that many people have heard of, like self-driving cars, and when will we have self-driving cars? And you might have heard of some of the initiatives like Google and Uber and so forth. So that's certainly an important and interesting development, on the road towards just a self-driving car. But I think one thing that's kind of interesting also is Toyota Research Institute is taking a slightly different approach. So rather than just a car approaching with no driver and you get in and it drives you somewhere, this is kind of like a human computer partnership. So these are examples of where the car is helping you to do something. So there's two modes, chauffeur mode and guardian mode. So in chauffeur mode, if you don't want to drive or you're disabled, or it can help you drive. So and it's pretty impressive if you watch the video demos of it, how it can identify things and navigate and steer around things and things like that. So Guardian is a mode that helps you drive safer. So it's a safety net against crashes. And if you're or if you're just say a teenage person learning to drive, it can assist you to drive better.
And that's also compliant with all the new laws that states are passing about self-driving cars, worried that they will be driverless, and so a lot of them are now requiring a human operator.
Yeah, so I think this is a very interesting approach. It's a more in my mind, kind of a more stepwise approach towards a full self-driving car. I think it's a really it's a good approach to make us just better drivers, and to get engaged in the driving process when you're about to crash. It can intervene before you crash to prevent that crash. and that sort of thing. So it's a really interesting video. I put a link to the video here. You can watch it, and the Toyota also explains, its background on it. Again, this is I first found about it in the book I read called All In on AI by Tom Davenport and Nitin Mittal. That book illustrates like 30 plus different very interesting, very contemporary like applications right now. A really good book. I would suggest you take a look at it. Okay, actually, here in the last slide before we go into questions and answers, again, I wanted to just sort of illustrate that one slide that I showed early on was sort of summarizes the whole thing. This is the one slide if you want to walk away with this is the one slide you should walk away with. So it talks about all the major key big areas of AI and some of the big ideas, predictive analytics, the concept of artificial intelligence and machine learning. We talked about programs that can learn without explicit programming, supervised and unsupervised learning. Neural networks are things that emulate kind of the human brain with digital, neurons that have weights basically, and the it can adjust those weights as it learns from input and feedback from output, and then artificial neural networks that adapt and learn and make intelligent decisions over time. So last time, the last time I gave this talk, Becca asked an interesting question, and that is, which I have a more better answer to than I did in the last time I gave the talk, which is like, what are interesting movies in AI? So I took a look at a lot of the movies, and in one of the talks I gave here, I said, it was an interesting thing I read in a book that said American movies tend to be pretty negative on AI. Like a lot of disaster scenarios, something always goes wrong. The AI robot takes over the world or threatens the world with total destruction. Whereas a lot of Japanese movies tend to be a lot more positive on AI. There are a lot of their views on partnering with AI and doing something good with AI is, I thought, an interesting cultural difference. But I looked at a lot of the movies that depict AI. Alita Battle Angel, After Yang, Source Code, AI, Brian and Charles, Singularity, iRobot, Endgame Technology. But I'll highlight a few that I think that I've seen that I think are really, really good to watch. So one is called Artificial Immortality. So it asks, if you could create an immortal version of yourself, would you? And it's this is a really interesting documentary. Project NIM is about this famous landmark experiment in the 70s that showed an ape could learn to communicate with language using sign language, and really interesting video. Now, I saw these on vudu.com, voodoo.com. They may be kind of hard to find, but they're available on streaming services. Of course, Bicentennial Man, Terminator, maybe the quintessential negative doomsday kind of movie, very popular though on AI. Marjorie Prime was really interesting. I thought I put a little star by it. So it's based on a play, and in the future, basically an elderly person has an AI sort of companion that she can interact with, which is a really interesting movie. Let's see. So another one was The Transcendent Man. So Ray Kurzweil is absolutely famous for his books, The Singularity and The Transcendent Man, that talks about that singularity point. He's super optimistic. I think 25 years is personally, I think, super optimistic. But anyway, an interesting documentary. And finally, we need to talk about AI. So this is I think quite a good documentary about thinking about some of those things that we talked about here. Before we hit superintelligence, thinking about some of those key issues. So, but you see, there's been lots and lots of movies on AI. Superintelligence is like a comedy movie actually, but it kind of illustrates it illustrates something that probably 1,000 years in the future, like where AI is instantly and pervaded all of society and is globally self-aware and interacting. But it does illustrate some interesting things about AI. And anyway, these are some of the my recommended movies. I put in stars here, so you can go back and take a look at it. Okay, so I'll stop here. Becca, did you have any questions you'd